What's up guys, Mizzo Frizzo here, and in this Unreal Engine 5 tutorial I'm going to be showing you how to draw a line trace with bullet drop and travel time over distance. So as you can see here, by the difference between shooting this surface and this surface to the right, that is about double the distance away. We've got quite a lot more travel time and bullet drop, and you can see if I just shoot this into the air, it's a nice even curve based on gravitational acceleration. And I think this is pretty cool because if I shoot a surface that's really quite close, you can't really see the travel time or the bullet drop whatsoever, but it is there. And the further away you shoot from, the more you can see this travel time and the bullet drop at work there. What sets this apart with other tutorials on this subject, I believe, is that most other people do sort of a sphere trace, and it is just lots and lots of sphere traces in a row. This one, although it is done on tick, is going to be a little bit more performant, and because it's a line trace, it will give you that data from the hit result. So if you don't really need to use a sphere trace, you shouldn't. It should be more for like melee attacks and stuff like that. This is great for something like a sniper rifle. So just before we get started, guys, a quick word from my sponsor. As per usual, guys, this Unreal Engine 5 tutorial is brought to you by you, my generous subscribers and viewers who have been so supportive over the past 12 months or so. If you find this video to be of any use or value whatsoever, please hit like and subscribe, and if you're so inclined, please do consider making a small donation to the channel via my Patreon. Link is in the description. I do also have some very exciting news for you guys. I have created a Discord. It is called Mizzo's Dizzo, and the first 150 people to sign up for a membership on my Patreon will receive lifetime access to Mizzo's Dizzo, even if you immediately cancel your membership. So with a one-time payment of $10, you will be made a permanent legacy member of my Discord. I will send you an invite link via Patreon and we'll get you onboarded and you'll be a permanent member of Mizzo's Dizzo with just one payment of $10. Do jump on this, guys, if this interests you, because I will not be extending this offer. It will only be offered to the first 150 people who sign up via Patreon for that $10 membership. But without further ado, guys, let's jump into this tutorial. Alrighty guys, now for the record I'm using Unreal Engine 5.4, but it should not matter which version you're using. The differences will be minimal, if any, and I'm just going to create a new project using the first person template, leave everything as default, and hit create. Now guys, I am going to be using an asset from this free asset pack called Military Weapons Dark on the Unreal Marketplace, but if this isn't available where you are, don't worry about that. It's just purely cosmetic and just for fun. And if you can't see your project here, just click Show All Projects, select your project, and then select the most recent compatible version, which is probably going to be 4.27, and hit Add to Project. And you'll know this one has been added to your project because you'll see this folder down here, Military Wep Dark. I'm going to head into Military Wep Dark and Weapons and find this Sniper Rifle B that I'm going to be using here. I'm going to first open up the skeleton here, Sniper Rifle B skeleton, and I'm going to add a socket to this weapon that we can draw our line trace from. So I'm going to right click on the root bone here and click Add Socket, and I'm going to rename this to muzzle, like so. Keep this socket name in mind because you will need it in a moment. And I'm just going to move this one up in front of the muzzle, like so. It doesn't have to be exact, but I'm just going to position it about the center of the end of the barrel here, and maybe about 1 millimeter in front of the barrel, like so. And I'm going to hit save and close this one. And the next thing I want to do is just basically swap out the skeletal mesh of this pickup weapon. So I'm going to go to first person and blueprints and open up BP pickup rifle. And over here in the components tab, I can select the skeletal mesh and change this skeletal mesh to my sniper rifle B, like so. And that is all we should have to do in here. So I can compile, save, and close that. And now I'm going to open up BP weapon component. The first thing I'm going to do in here is just delete this whole first section here when we fire. I'm going to keep this montage here, and I'm also going to go to the class defaults and change the skeletal mesh asset to my sniper rifle B. And I'm going to right click and find the node play animation, plug it into the fire here, and select my fire sniper rifle W. Plug this in here. Now we will need to spawn our bullet blueprint, which we're going to go on and make in a moment. But just very quickly, I'm just going to double check that this skeletal mesh has changed, and when I fire, it's playing that firing animation. Now, I'm not going to go into fiddling around with the animations and the position of the weapon or the socket or anything like that. Like I said, the sniper rifle is not crucial to the logic that we're setting up here today. It's just for cosmetics. Alrighty, the next thing we want to do is create our bullet blueprint. So I'm going to right click here and go to blueprint class, actor, and let's call this BP underscore, I'm going to call it ballistics projectile. Now, we're not using projectiles, but this is basically, a ballistics calculation. We're adding, gravitational acceleration downwards to our line trace. So it is basically ballistics, although we're not going to go into doing aerodynamic drag or anything like that today. I'm going to open up this blueprint class, and the first thing I'm going to do is add a static mesh, and you can call that bullet. And we also need to add a component in here that's going to do all our line trace logic. So we're also going to right click here and create a blueprint class and select actor component right here. And let's call this BPC underscore ballistics, something like that. Doesn't matter too much. Open this up, and in here is where we're going to do most of the logic for our line trace with our bullet drop. So the first thing we need to do is on event begin play, we need to set a few variables and basically kick everything off here on event begin play. So let's create a few variables first. I'm going to call the first one velocity. That's going to be a vector. Let's create another one called speed. That's going to be a float. And we need a start position and an ending position. So let's just call this start pos. That will be a vector. We can duplicate that. Call this one end position. And let's also create one called, delta time. That will be a float. And that should be all we need. I am going to start off by setting the velocity. And so basically what this is going to be is, a sort of record of the current trajectory of our bullet. So this will be sort of used throughout the calculations and then updated at the end. And what our blueprint is going to do is basically draw a series of line traces from start position to end position, and then it's going to recalculate the velocity and then draw another little line trace and just many small line traces to give us that arc. What the velocity is going to be is what we can do is get the owner, and this will be our BP ballistics projectile. We're going to add this component to our BP ballistics projectile, and we're going to get actor forward vector, and we're going to multiply that by our speed. And while we're here, we might just set a default value for speed. So this is basically the velocity, the initial velocity of your bullet. Like I said, we're not adding in aerodynamic drag or anything like that, but you most certainly could add that onto this. So I'm just going to set this to 50,000. And that is 500 meters per second. So that's not super quick, but I'm just making this a little bit lower to sort of exaggerate, you'd be able to see the bullet traveling a bit more clearly. The next thing we want to do is get owner again and get actor location. And this is going to be that muzzle socket that we created on our weapon. That's where we're going to spawn this actor. So its initial location is going to be that muzzle position. I'm going to set the start pos as this, the actor location. And basically all we want to do after that is put in a delay. So we'll put in a delay of say 10 seconds and we'll destroy this actor after 10 seconds. So once again, we can get owner and destroy actor. So that's sort of the initial velocity and start position set up. And then what we want to do on tick is basically, do all our calculations for the trajectory and draw a line trace, and that will kind of loop on tick until this actor is destroyed. So what we can do is set our delta time variable here as delta seconds off event tick, and we can go from there. And what I might just do is grab these two here, and we're going to set our start position as the actor location right here. And then we're also going to set the end position as our start position, plus our velocity multiplied by our delta time. So basically what we're doing here, every tick is we're setting the start position as where the actor is, and then we're calculating an end position here by adding on velocity multiplied by delta time to our start position. And then we're going to draw a small line trace between the start position and the end position. And then next tick, it's going to recalculate the velocity again. And then next tick, it's going to draw another small line trace, little small line traces all in an arc to give us that bullet drop. Now this would probably be better done in C++ with this amount of math, and the more complexity you add to this, such as aerodynamic drag and stuff like that, you really would want to set this up in C++, but I think this is cool anyway, so let's do it. The next is line trace by channel, and that's going to go from our start position to our end position, and I'm just going to change the draw debug type to for duration. And let's just make this 10 seconds. Actually, let's make it something like 6 seconds, because otherwise it will hang around for 10 seconds after the actor's been destroyed. Yeah, so let's just make this 6 seconds. And then what we want to do is check if we've hit anything. And if we haven't hit anything, we're going to, draw another trace, draw another trace, draw another trace until we do hit something. So the next thing we can do is get our owner again and set actor location. Set actor location. And we're going to set it as the end position. So we've drawn one small line trace, and then we've moved our actor to that end position of that line trace, and that's going to be our new start position on the next tick, if that makes any sense. So that's the first thing we want to do. And then we just want to sort of add our gravitational acceleration. So we can set our velocity here, and what we're going to set it as is our velocity minus, and we need to do a little bit of math here, it's not too crazy. We will make a vector, and what we're going to make the vector as is our gravitational acceleration, which is 9.8 meters per second, but as you know, in Unreal we use centimeters, so this will be 980 centimeters per second, and we're going to multiply this just by 10. This is probably, you know, best to think of this as just kind of a multiplier that accentuates this gravitational acceleration. If you were going to do these calculations legitimately and make them, you know, a bit more realistic in line with actual physics, this might be something like mass of the projectile or something like that. So we're going to multiply this vector by our delta time, and we're subtracting that off of our velocity. So we're subtracting 980 centimeters per second off of the z-axis on our velocity and setting the velocity as that. So at the end here, it's setting the velocity at, you know, minus our gravitational acceleration, and then next tick, that will sort of factor into the velocity here, the end position of our line trace, and it will just keep on doing this until we hit something, or until the actor is destroyed after 10 seconds. But, you know, if you're shooting something that takes 10 seconds to hit, you know, it's pretty unrealistic, so it's going to be destroyed after 10 seconds. And then all we really need to do here, we don't really need to do anything, but you're probably going to want a hit result. And what we can just do is grab these two nodes right here, and we can set our actor location as the hit location. So once it does hit something, it will just set the location as that impact point. You know, and then you could also use that location to place sound at location or spawn a bullet hole decal or whatever you like. But that is pretty much all we need to do in here. And this blueprint component will then be added to our BP ballistics projectile. So we can find our, BPC ballistics, add that in there. And I'm also going to set this static mesh as a static mesh of a bullet. Now this weapons pack doesn't come with great bullet meshes. They're just kind of empty casings. So this is not ideal, but we'll just set it as this anyway. So, and I may need to rotate this in a moment, but I'll show you how to check its orientation at runtime, and we'll rotate this if we need to. And then all we need to do is spawn this blueprint at the location of the socket that we created. So in our BP weapon component, we can spawn actor from class. The class will be our BP ballistics projectile, and the spawn transform, we can get socket transform, and the socket that we're looking for is muzzle. Now if you're using the FP gun, you just want to check what muzzle you want to use in there. So if you are using the FP gun, you can go to FP weapon and mesh and find SK FP gun skeleton. Open this up, and you can see there is a muzzle socket there. You just want to spell it correctly with that capital M, or it may not work. You know, and you could adjust this if you really wanted to. Okay, so that should be pretty much everything. We are hitting fire, we're playing an animation on our sniper rifle, playing a montage on our arms, and we're spawning that actor at the muzzle. And then on tick, it's going to draw these tiny line traces sort of all the way in an arc. And I just want to check that I set my speed, to 50,000. Now, we won't really be able to see this in action too well with such a small, close environment. So I'm going to make a bit of space here, get rid of some stuff, and I might select these three and scale them up like so. So we've got a bit of a range here, and I'll move this out to the end and scale this one up. So we got something to hit, and nice. You should be able to see our bullet traveling now. I might also just, whoops, meant to duplicate that, sorry about that. I might also move this one really far away and just make it, just make it massive. So we have something else in the distance to shoot at, and I'm going to move that even further away. Nice. That should all be working now. So if we hit play, I'll grab my sniper rifle here, and just going to turn the volume down so I don't destroy my eardrums. And we can see that bullet travel time there and the drop. And if we shoot this surface that's further away, it's quite a lot more travel time. And what I think is really cool about this is if I shoot this surface that's a lot closer, you'll see it's basically instantaneous, and it's pretty hard to see the bullet travel time or the drop, but it is there. And the further away we fire from, you can start to pick out the travel time there, and you can start to see the bullet drop, which is pretty cool. Now, realistically, you might want to change this speed of your projectile to something a little bit higher, say 80,000 for 800 meters per second. And, you know, you might, because you've increased the speed here, you might dial this multiplier down. Let's change that to 8 and see how that looks. But it really does just depend on your game and what you're going for. You can see here that 800 meters per second is pretty quick, but I think that's a little bit more realistic, and that's a nice amount of bullet drop from that distance as well. One thing you might want to also add is in the ballistics component here, where it ends right here, we might want to do something once it hits to disable tick, because otherwise it's probably going to keep drawing the same final line trace until the actor's destroyed. So maybe what you could do is set tick enabled, set component tick enabled to disabled, like so. You know, but you could do whatever you want here. You could play a sound at location, spawn a bullet hole, whatever, and then disable tick, or destroy the actor if you don't need it anymore. And the very last thing, guys, is just to check that that static mesh is rotated correctly. So if I fire and then quickly pause it, I can press F8 to eject, and if I dial my camera speed down a little bit, we can see that this projectile, this static mesh, needs to be rotated by 90 degrees. It's not actually clear to me which direction this needs to rotate, so let's just try and figure this out. We know it obviously needs to come down like this, but then I'm not sure which direction it will need to face. So let's just have a look and see how that has affected it. It looks a bit odd. It looks like it's kind of you know, not in line with the line trace just because it's going up. I don't know if I'm the only one that can see that. It does, to me, look like it's just going up a little bit. So what I might do, I might just turn off rotation snapping and just angle that down ever so slightly, because I think that looks better. And quickly check how that looks now. That may have been a little bit too much. So I'll just split the diff and leave it about there. Nice. Alright guys, if this tutorial has been of any use or value to you whatsoever, please hit like and subscribe, and I will see you on the next one.